Today we will discuss the solutions to the midterm exam from the previous year. So let's start with a description of the problems first of all, then we'll go through each of the problems in more details. So in the first problem, we're given a ball with some volume. We need to figure out the rate of change of the volume with respect to the radius. In the second problem, we need to find out the derivative of the polynomial with the different powers. In the problem number 3, we're given a curve with implicit equation. We need to figure out the equation of the tangent line at some point, and in order to make the tangent line, we need to find the derivative of the y with respect to the x implicitly. So in the problem 4, we're given a function, and we need to find out its extrema values, its maximum and minimum points. So first of all, we need to figure out the explicit form of this function. Then in the second problem, we need to figure out the maximum and minimum values for this function. In problem 5, we're given a function which has discontinuity at some point, and we need to figure out its derivative at this point using the definition of the derivatives. In problem 6, we're given an integration problem. So we were given a function, we need to find out its integral using the trigonometric substitution. We'll skip the problem 7 today. In problem 8, we need to find the area enclosed by these two curves, and we're going to use the integration in order to find this area. So now let's consider each of the problems in more details, one by one. We're given the ball in a form of sphere, which has the volume 4/3 pi r cubed, and we need to find out the rate of change of the volume with respect to the radius. Basically, we need to find out the derivative of the v with respect to the r. So, which is 4/3 pi, the constant, which doesn't depend on r, multiplied to the derivative of the r cubed, which is 3r squared. Right? So we'll get 4 multiplied to the pi r squared, and we're given that initially the r was equal to the 2, so that's why if we substitute the 2 there, we'll get 16 pi. So the rate of change of the volume with respect to the radius is 16 pi. So let's go to the second problem. We're given a polynomial, so derivative of this function is equal to the derivative of the first term plus the derivative of the second term. We can find the derivatives separately. So first of all, in order to find the derivatives of this kind of functions, we need to remember that the derivative of the power function x in the power of some n is equal to n multiplied to the x in the power of n minus 1. So that is why in order to find the derivative of this function or this function, we need to bring them in this form, x in the power of some n. So minus x in the power of minus 1 is actually minus 1 over x. So derivative of this one is equal to the minus, here, this minus, multiplied. The minus 1 comes down, so minus 1 multiplied to the x in the power of minus 1 minus 1, which is minus 2. So the answer is x in the power of minus 2, or basically 1 over x squared. So in order to find the derivative of the second term, we again will write down this in the standard form, x in the power of n. So we know that the square root was equal to the x in the power of reciprocal of this 2. So that is why it is equal to this x in the power of 1 over 2, which is square root of x, and the power of cube. And we know that if we power up the x in some power of 1 over 2, and then power up this to the 3, this is equal to the x in the power of 3 multiplied to the 1 over 2. So we need to find out its derivative, and according to this rule, n goes down, so 3 over 2 goes down, x, and we need to subtract the 1 from the 3 over 2, which is 1 over 2. So the answer is 3 over 2 multiplied to the square root of x. So the derivative of the function will be at the end is equal to 1 over x squared plus 3 over 2 square root of x. Let's go to the next problem. So we're given a curve. We need to find out the equation of the tangent line. So first of all, let me remind you that the equation of the tangent line is given as f of a plus f prime of a multiplied to the x minus a. So this is the equation of the tangent line to some curve, was the equation f of x and y is equal to the 0 at some point a. So here f of a and f prime of a basically is equal to the y coordinate of the point at this point a, and f prime of a, this is the y prime at this point a. So basically we need to figure out what is the y prime from the implicit form of the equation, then figure out what is the y prime exactly at this point a. So first of all, in the first part, let us figure out the implicit derivative of this curve. So implicit derivative means that we will take out the derivative of all the terms with respect to the x. So derivative of the 2x cubed with respect to the x is 6x squared minus. So derivative of the 3y squared here. So you don't see here the x here, right? But we keep in mind that y is some function. We don't know what is the form of this function, but this function definitely depends on x. So we need to use the chain rule. So basically, we'll take out the derivative of the 3y squared with respect to the y first. So this will be 6y, and multiply this to the derivative of the y. So basically, just simply y prime is equal to the 0. And we need to figure out what is the y prime from here. This is equal to x squared divided to the y. So on the next part, so we're given the y, right? So we need to figure out the equation of the tangent line at the point 2 and 2. So this is the a basically, and this is the f of a. Okay, so in order to find what is the, or basically y, right? Or this is the x and y. So x and y coordinates, or a and f of a coordinates. So all of these things are equivalent. So in order to figure out the f prime, which will be simply f prime, y prime, which will be simply equal to the f prime at the point a. So we need to substitute the x here with the 2, and y here as well with the 2, because x and y are equal to the 2. So this will be 2 in a square divided to the 2, which is equal to the 2 simply. So now we need to put everything to this equation with the red in order to find the equation of the tangent line. So the equation of the tangent line is equal to the y is equal to f of a, which is y, is equal to the 2, plus f prime of a, which is y prime at this point a, which is also is equal to the 2, multiplied to the x minus a, which is also equal to the 2. So we'll get equation 2 plus 2x minus 4, or basically 2x minus 2. So this is the equation of the tangent line to this curve at the point 2 and 2. So let's go to the next problem. In this problem, we're given a function which depends on, which is given in the integral form. On the first part, we need to figure out what is this implicit form. So basically, we need to get rid of this integration by just simply integrating this function. So basically, we'll integrate here the function x squared minus ax plus t with respect to the x. So basically, in all of the three terms, we consider the x as the variable, everything else as the constants, right? So including a will be also considered as a constant, which doesn't depend on x. So antiderivative of the x squared is equal to x cubed over 3 minus antiderivative of the minus ax is basically ax squared over 2. Here a is considered just a constant, plus as the 2, as the last 2 here. So plus the antiderivative of the 2 is 2x. So we need to put the values of the 0 and a here. So if I put the values of the a, I'll get the a cubed over 3 minus a multiplied to the a squared over 2 plus 2 multiplied to the a. right? So if I put all the zeros to the axis, so this will be 0, so I don't need to put this in order to evaluate this. Basically, this should be minus 0 in a cube over 3 minus a multiplied to the 0 in a square over t plus t multiplied to the 0. So the answer is a cube over 3 minus a cube over t, which is minus a cube over 6 plus ta. So basically, if we figure out the explicit form of the function, f of a is equal to the ta minus a cube over 6. On a b part, we need to figure out its maximum and minimum values. So in order to do this, first of all, we need to figure out its extremum values, right? So we know that we're critical points. So those are the points where the derivative of this function is equal to the 0. So let me take the derivative first of all. Derivative of this curve is equal to the t minus 3 divided to the 6a squared, right? So we need to equalize this to the 0 and figure out the values of the a, which would satisfy this equation. So this is equal to 12 is equal to the 3a squared, right? So I'm going to find the roots. So the roots are a is equal to the plus minus 2. So let me remind you, first of all, the derivative of this curve is equal to the t minus 3 over 6 a squared, right? So I figure out that the roots of this curve of this function f prime of a is equal to the plus minus 2, and now I need to find the increasing and decreasing regions in order to figure out what's minimum and what's maximum. So in order to do this, so let me just put some number from here, for example 3 to this curve, right? 3, and let me see what is the sign of this curve. So f prime of 3 is equal to the t minus 1 over t, which is 3 over 6, right? Multiplied to the 9, basically t minus 4 over 4 and a half, which is minus minus 2.5. So here I will have minus. Then here I'll have plus and minus. So basically in this region the function is decreasing. Then here it's increasing. Then here it's decreasing again. Right? So it means that at a point minus t it reaches its local minimum. And at the point plus t it reaches its local maximum. So if we're required to find what is its local minimum and what is its local maximum, so we need to find out the value of the function at those points. So f of a, let me first of all write, it was ta minus a cube over 6. So we need to evaluate this function at the t. It will be t multiplied to the t minus 8 over 6, right? So basically, which is 424 minus 8 over 6 is equal to 16 over 6 or 8 over 3. At a point and its local minimum is, so t multiplied to the minus t minus t, which will be minus 8 divided to the 6, right? So this will be minus 4 plus 8 over 6, right? So this will be minus 24 plus 8 over 6, or minus 8 over 3. So the local minimum of this function is equal to the minus 8 over 3. It reaches its local minimum at the minus 2. Local maximum of this function, is equal to the 8 over 3. It reaches its local maximum at the point 2. Let's go to the next problem. Problem number 5. We're given a curve. We are given a function which has some discontinuity at some point, and we need to find its derivative at this point using the definition of the derivatives. So first of all, so f prime, but let me remind you, so derivative of the function at some point is equal to, so f of a plus h minus f of a divided to the h, and we need to find its limit when h goes to the 0. So we're required to find out its derivative at the point 0. So a part is, so we need to find the derivative of this function at the point 0. So this is the limit of f of a, which is 0, right? Simply h, minus f of 0 divided to the h when h goes to the 0. So what is the f of h where h is not equal to the 0? So you see, so for all the arguments which are not equal to the 0, the function's value is equal to this one. So we just need to substitute the x with the h. So it will be limit if h goes to the 0, h squared multiplied to the sine of 1 over h, right? Minus f of 0. So what I will have when I put the argument to be equal to the 0 is 0 divided to the h. So we need to find out the limit when h goes to the 0 of the h multiplied to the sine of 1 over h. So basically we know that its limit is like this, the limit of this function is in between the two curves, right? So previously we've learned about the Sandwich theorem. So if we're given the three functions like f of x, which is always less or equal than g of x, which is always less or equal to than h of x, and if the limit of the f is equal to the l, and if the limit of the h is equal to the l, then obviously the limit of the g will be also equal to the l. So basically our function is here the g, h multiplied to the sine of 1 over h, so which is always equal, less or equal than the h, and this is always more or equal than the minus h, right? So minus h, because of this sign, right? So sign, the range of the sign is always the between minus 1 and 1, right? So that is why when the sign has its maximum value, it will be simply 1, right? So that is why its maximum value of this function is h. And the minimum value of the sign is minus 1, so that is why minimum value of this function is minus 1 multiplied to h. So we know that when h goes to the 0, this function goes to the 0, this one goes to the 0, so that is why the limit of this one is also 0 according to the Sandwich theorem. So the derivative of this curve at the point 0 is equal to the 0 simply. So on the second problem, we need to figure out the derivative of this function. When x is not equal to the 0, then we just need to use the derivation rules in order to find the derivative. We're given the curve f of x is equal to x squared multiplied to the sine of 1 over x. So we just need to figure out what is f prime of x. So we need to use the multiplication rule, right? So this is the derivative of the first part, tx, multiplied to the derivative of the second part, sine of 1 over x, plus the first part multiplied to the derivative of the second part. And here we need to use the chain rule again, right? So the derivative of the sine of 1 over x is cosine of 1 over x, and then multiplied to the derivative of the 1 over x, which is minus 1 over x squared. Okay, so which is equal to tx sine of 1 over x minus cosine of 1 over x. Okay, so in the third part, we need to figure out the derivative, second derivative of this curve at the point 0. And in order to find this, we can use the definition of the differentiation. So which is equal to the limit of h goes to the 0, f prime of h minus f prime of 0 divided to the h. So here nothing is like is different, right? So previously we've got like f prime of 0 is equal to the limit of f of h minus f of 0 divided to the h goes to the 0. And obviously, analogously, if I would like to find the second derivative at the point 0, I need to take here the difference of the first derivatives, right? So I know what is the first derivative when the x is not equal to the 0, right? F prime of h is equal to this one. So f t prime at the point 0 is equal to the limit of tx sine of, or sorry, I need to substitute the h now. Th sine of 1 over h, because I'm finding f prime of h, right? Here, f prime of x is equal to this one. So that is why prime of h will be the same function where instead of x, I just need to find y dh. Minus cosine of 1 over h, right? Minus, so we figure out f prime of 0, right, previously. So f prime of 0 is equal to the 0 here. So we found out here previously. So minus 0 divided to the h. So let me divide every term to the h first of all. So on the first part, we'll get simply t sine of 1 over h minus 1 over h cosine of 1 over h. And here again, we need to use the like a sandwich rule in order to evaluate the second limit here. So I know that the cosine is always between minus 1 and 1, right? So it's some constant. If I multiply this constant to the reciprocal of the h, the reciprocal of the 0, so 1 over 0. So basically this thing goes to the 0. If the h goes to the 0, this thing goes to the infinity. And this is some constant, right? So always in a range between minus 1 and 1. So that is why its limit does not exist. So basically it will be infinity. So the conclusion is this function has the first derivative at the point 0, and this is equal to the 0. And it doesn't have the second derivative at this point. Let's go to the next problem. So in this problem, we need to evaluate this integration using the trigonometric substitution. So if you remember, so for this kind of problems, we need to make the substitution. Yes, x is equal to sine of t, right? And we just need to substitute all the x's in this integration with a t. So here I've got one more x here in the form of dx, so I need to substitute this. In order to do this, I will take the derivative of the x with respect to the x, which is equal to the 1, right? And I have to multiply this to the dx in order to show the variable of the differentiation. And from the right, I need to take the derivative of this function with respect to the t, which will be equal to the cosine of t, and obviously I have to multiply this to the dt. So I will substitute all the x's and all the dx's with the t's and dt's. So the integration of the x squared divided to the 1 minus x squared dx is equal to the integration of x squared is sine square of t, and 1 minus sine square of t is equal to the cosine square of t, and the square root of cosine square of t multiplied to the cosine of t dt, right? So because dx is equal to the cosine of t dt. So if I take the square root of the cosine square of t, it will be simply cosine of t, so I can just cancel them. And this will be equal to the integration of the sine square of t. So integration of the sine square of t dt. So in order to integrate this function, I need to decrease the power of the sine. And I'm going to use the formula of the double degree of the cosines. So this will be 1 minus cosine of tt divided to the 2 dt. And I can integrate separately each of the terms. So the integration of the first term, it will be 1 over t, and the integration of the second term is slightly difficult. So this will not be simply cos sine of tt, so this will be 1 over t sine of t, so because of the chain rule. So it was this t, it becomes 1 over 4 sine of tt. So the reason is that if you take the derivative of the sine of tt, it will be cosine of tt multiplied to the t, and this 1 over 4 will be cancelled with this t, and you will have this, exactly this term. So that's it, this is the answer. So if you want, you can resubstitute back with the x, or if you need to calculate, so plus c here, sorry. So if you need to calculate the definite integral, then you can calculate this with this t as well. And the last problem is we need to find the area between these two curves. So if this is easier for you, so you can just like a change with the letters of the x and y, so which will be usual form for us. The first function will be y is equal to the tx squared, which seems as a similar parabola, and the second curve is equal to the y is equal to the 4 plus x squared, right? So you remember the transformation of the functions of the curves. So if we're given the simple parabola as the y is equal to the x squared, it would be like a similar. If I multiply this to the 2, it will be just stretched it is by the 2, right? So this will be this kind of parabola. It will be stretched vertically, sorry. So, and the second one is the same as the x squared, but I need to put this up to the 4 units. So the second one will be similar to this, like this. And I need to figure out the area here. And I know that the area between these two curves, so let me take it as a g, and let me take this one as the f. It will be the integration of the of the g minus f dx, where x changes from this point until this point. So in order to find these points, we need to solve the system. So y is equal to the 2x squared, y is equal to the 4 plus x squared. So the solution of the system gives us the intersection points, the coordinates of the intersection points. So in order to do this, I will just substitute the y with the 2x squared. So 2x squared is equal to the 4 plus x squared. So if the x squared goes to the left, it will be simply x squared is equal to the 4. So x is equal to the plus minus 2. So basically x changes from minus 2 to the 2. So we need to integrate the difference of the g and f from minus 2 to the 2. So integration of 4 plus x squared minus 2x squared with respect to the dx of all of this thing from minus 2 to the 2. And let me first of all simplify the brackets. So minus 2 to the 2, 4 plus x squared minus 2x squared, it will be 4 minus x squared dx. So first of all, I need to find out the antiderivative. So this will be 4x minus x cubed over 3. I need to put the values minus 2 and 2. So if I put the 2, it will be 8 minus 8 over 3 minus, then I need to put the minus 2, it will be minus 8 plus 8 over 3. So if I multiply it with this minus, it will be 8. This is equal to the, it will be 16 over 3 plus the same thing, 16 over 3, so which is equal to 32 over 3. That's it. So we considered all the problems from the last midterm.